Hey guys, hopefully you all watched yesterday's video and you had a go at these in the Google Classroom. What we're going to do is just edit these really quickly. And so we know hydrogen is 1s. Hydrogen is the 1s orbital and it's got 1 electron. And you really need a shortcut to make this superscript. And then helium is of course 1s2. So I think most of you got those two, at least those of you that handed in the work. I can't tell because I'm making this video before I've even put it up. Lithium is element number 3, and so we've got 3 electrons, which means we've got 1s2 and then 1s1. And what we can do, I'm just going to leave those big ones, it takes too much time to make it small, but these are small. Carbon, as we did yesterday, 1s2, 2s2, sorry, there should be a 2 there, my bad. And then this should be 2p6. So again, all these numbers there, it's small, up and up the top, but formatting on Google Classroom, I can only do it tiny. Neon has got a full outer shell, so it's got 2 electrons and then 8 electrons, which makes 10 electrons. And so by having a full valence shell, we can say it has a full second energy level. Sorry, I'm making a lot of mistakes today, so this should be a 2p2. Because these numbers have to add up to 6. Because carbon's got 6 electrons. That one that I had before, that is for neon. 2p6. We add up these electrons, 6 plus 2 plus 2 equals 10. That adds up to neon's 10. Okay? SSP. This is following the almighty order of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Okay? And sodium has got 11 electrons, so we have the same as neon, and we just tack on a 3s1. We can do something a bit sneaky. We could do or. We can just write this. Sorry. This. Ne 3s1. What this is saying is we have the noble gas configuration for neon, which is this, and then 3s1. So instead of writing out this whole thing, we could just write neon, which is saying we have the noble gas configuration for neon, which is here is the same as here, and we just write 3s1 at the end of it, and we make that tiny. Okay, so hopefully most of you got that. Now moving on to d orbitals. D orbitals are split into 5 suborbitals, and they look like this. Look a bit crazy. Each suborbital can hold up to 2 electrons each. So 5 times 2 equals 10, meaning d orbitals can hold 10 electrons total. 3d10 represents the 3d orbitals holding 10 electrons total. Again, can you take these notes down in your books? And these are our orbitals. If you do any sort of inorganic chemistry at uni, this is so important, knowing what these look like and knowing how they involve in bonding. But we're not looking into that far. We just sort of need to know what they do and how to write them down. So, write the Spdf notation. So Spdf notation is basically the 1s2, 2s2, 2p6 for the following elements. So let's try this together. Fluorine. First thing, how many electrons in fluorine? Well, it's 9. So we know this has 9 electrons. So I'm just going to write a little 9 there. And how we get that is always, we start off with 1s2, 2s2. Okay? Always start off with that, pretty much, for any atom, because that gets us to 4. And then we need 5 electrons somehow. And the next thing we can go to is our 2p, and we go 2p5. Again, these numbers should all be small, but my shortcut is not working for them. And as you can see, if we just got to 2p6, it comes to the noble gas configuration of a full valence shell, and so fluorine would be happy with an extra electron, but it hasn't got it right just yet. Aluminium if I remember right, this is element number 13. And so we can, I'm just going to write down neon here. Neon. Because that's our 1s2, 2s2, 2p6. Then we've got 3s1. Then we've got 3p1. Oh, sorry, 3p2, 3p1. So that's 10 electrons there, and then another 3 electrons here. So it adds up to 13. Okay? Remember our neon, if we wanted to write it out, would just be 1s2, 2s2, 2p6. So that'll be the full thing written out, with the small numbers up there like that, and this will be 13. Calcium is element number 20, so it's got 20 electrons. I am not going to write down the whole thing, so I'm just going to write down neon to save some time. And then we've got 3s2, 3p6. How many is that? That's 18. We need 2 more, and 4s2 is our extra electrons. So what we've done is calcium sits right here on the periodic table in element number 20. We've done 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we get there. We just read across the table until we get there. Okay? Pretty simple. This is a way of thinking about it. Some people like to draw it this way. So we draw out 1s, 2s, 3s, 4s, 5s, 6s, and then 2p, 3p. And this tells you how we fill it up. We draw arrows. I don't like doing it this way, but if you think this may be the way that you learn, basically we start at the top and we follow the arrows down. So we start at 1s, then we go to 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. We're not really getting into this high up on the table, so we don't need to worry about it too much. 5s is about as high as you will go. Basically, lower energy orbitals get filled up first, which is a very important rule. Hund's rule. And if you can write this down, this will be our last note for today. Each orbital will fill up with 1 electron before doubling up. So what do I mean by this? Let's take a look here. Here we've got 1, 2, 3, 4, 5, 6, 7 electrons, meaning we've got nitrogen here. And what's going to happen when we fill up our nitrogen, we're going to put 1 electron in here, 1 electron in here, 1 electron in here, 1 electron in here. Then we get to filling up our 2p's, we're going to put 1 electron in each of them. We're not going to do this. Also, this is how we draw electrons. Each of these, so 1s can hold 2 electrons, so we draw it like this. 2s can hold 2 electrons, so we draw it like this. 2p can hold 6 electrons. So what we could do is double up each of them to make 6 total. But right now we've just got 3 unpaired electrons, which it does because this is lower energy and it's more stable doing it this way than like this way. Okay? So if you could write this in your book and maybe draw something like this, so we know what it means. Alright, thanks guys for watching.